Alright guys, this is science for April 2nd, Thursday. And so what I need you to do today is largely just read page 406 through 411. So just make sure we get that read. So it'll be straightforward, just read that and then we'll clean it up like we normally do. So go ahead and pause the video here in a second and read page 406 through 411. So you can pause at this point. Alright, so this is kind of fun for me. I like this lesson because you get to do a little bit of math, and I like math better than science most of the time. Sorry, I know y'all probably reverse of that, but what y'all aren't as cool as me, which is already established. So, but y'all are getting there. Y'all get there eventually. And I know Brianna's over there doing her thing probably at this point. So, Punnett squares. Everybody say yay. So, Punnett square is basically going to work a little bit of math into it, and so that's why I like them, like I said. So basically what a Punnett square is, it allows you to track how information is passed on from one generation to the next. So passed on from the parents to the children. And so you get A and A, basically you're going to combine them. And so this first column is always going to combine this letter with that letter. So if they're passing on this information, I don't know what it is because I've just made it up, but passing on this big letter A to this big letter A, big letters are usually dominant traits. Smaller letters, lowercase letters are recessive traits. And so you're going to pass along two capital A's, basically just fill it in. So this first one will pass an A, and then the second one will pass an A. So this one comes here, then this one comes there. And so that's how you get the AA combination. Okay? Now, for the next square, which will be over here, you're going to pass along this A from that parent is going to pass to here. And then this A is going to pass along to here. Because you basically keep it in the columns. So notice that this A is in this row right here. So this A passes to both of these. Then this A here is in this column. And so it passes there. And then this passes there. And so that's kind of how it's going to work as we work through it. Alright? So when we do this bottom two, you have this row that's going to be made up of this small a. So this small a passes into this row. But then this A right here is this top A, this capital A, is going to pass to here. So you get A. So the small a and the big A. Then for the fourth one, you get this small a, and then you get this small a. So it just kind of works itself in. So notice what happened. This A right here is in this first row. So this A right here passes into the first row. This A right here passes into this bottom row. This A right here goes into the column. Then this A right here goes into the column. So you just basically keep them on their rows and their columns and they match up. So where does the math come in? Well, if you look at it now, basically you can do probability with it. Because now I can say, okay, what is the probability of a parent with a dominant and recessive, and a dominant and recessive passing along two dominant traits to their kids? So it has to be a capital A, capital A. Well, there's only one box that has one capital A, so the probability would be 1 over the total 4 boxes. So passing along an AA, two capital A's, would be 1 over 4. That would be the probability of these two parents passing on two dominant traits to their son or daughter. And so, how many? You can do the same thing for a big A and a little a. So I want a big A and a little a now. What's the probability of these two parents passing along that to their son or daughter? Well, we have a big A, little a here, so that's 1. We have a big A, little a here, so that's 2. And so that's the only 2 out of the 4. And so it would equal 2 over 4 would be the probability, or 1/2. So the probability would basically be 50% that they would pass along one dominant, one recessive. And then what's the probability of passing along two recessive genes, or two small a's? Then that would be just this one right here out of the 4, so it would be 1/4. And so you can kind of see what's the likelihood of you having blue eyes, or the probability of you having brown eyes, or things like that based on what your parents have. That's how this is going to work. So remember, it's just the columns, columns and rows. So this A comes here, that A is also going to go there, and and then this A can come in the column. So it just kind of works it through right there, and that's called a Punnett square. Okay, so that is on page 406. They give you some illustrations. So if you look on 406, there it says steps to making a Punnett square. They give you those steps there in that box. So that's another way you can look through it as well. So that's really important. If you look at page 407, there on the right-hand side of page 407, basically what I did here, this is a heterogeneous, heterogeneous, there we go. So heterogeneous is where you have a big letter and a smaller letter. So it's where you have one dominant, one recessive. They're not the same. If both of these, change this to where both of these are capital, both of these are dominant, then that's homogeneous because you have two of the same. If you had two of the small a's, two of the recessive, that would be the same. So two dominant, two recessive, then that's going to be homogeneous. If you have one of each, that's heterogeneous. And so if you look at the Punnett square on page 407, notice that you have a homozygous yellow, which means that you have two Y's that come together, two capital Y's, two dominant traits, and then it says a homozygous green parent plant, but both of those on the left-hand side there are going to be recessive. And so you have two of the small Y's and two of the big Y's. So then that first one will take one big Y, one small y. Then the second box there will take, going through the column, the second one will take one big Y, one little y. And then looking at the bottom column there, or bottom row, you would have one big Y, one little y, one big Y, one little y. So notice that the actual completed Punnett square there on page 407, notice that each box has one big Y and one little y. So we had none that had both. We never got this. There was no way to do that. And so it's going to be 100% probability that you wind up with one big Y, one little y. So depending on whether it's homogeneous or heterogeneous or homozygous, heterozygous, is going to determine that how the actual Punnett square works. But it still just works the same as far as how it lines up. So that is on page 407. So again, if you need additional help with getting the Punnett square started, page 407 there on the right-hand side is a good example, and page 406 there is a good example as well. A couple definitions before we go. You have on page 408, you have a pedigree chart. Those, instead of using breeding experiments, genetics use pedigree charts to study genetic traits in humans and other long-lived organisms. So a pedigree chart is essentially a family tree that includes information on the trait being studied. So a good example of that is going to be on page 409 there. So it's basically just the family tree and just breaks down, okay, this is how the family tree aligns itself. And so there, you don't really need to know that in great detail, but you mainly need to know the difference in how a pedigree chart looks and a Punnett square. So you need to know the difference in those. So the heredity pedigree chart shows you basically the family tree. And the last few definitions here are going to be selective breeding on page 411. Selective breeding there, it says, man in thinking God's thoughts after him has used this principle of variety along with the laws of heredity to develop improved varieties of wheat and other agricultural products through selective breeding. For example, a variety of wheat that has unusually high grain yields could be bred with another variety that has increased disease resistance to produce a new variety that has both high yields. And so that's going to get into genetic engineering. And so basically you're looking at the Punnett square. You're saying, okay, this one produces high yields. This one produces high yields. So let's try to breed these in such a way that we can get all the good traits into this one type of wheat. And so that is called selective breeding, where you're trying to get all the good traits into that one specific thing you're looking at. And then, so that is essentially the lesson as far as the big items that you need to pay close attention to. Punnett squares are very important. So what I would suggest you do is definitely look at those Punnett squares. If you have, I can go back through this again later if you need it. So if you have any issues with this, then let me know through the app or whatever. That way I can go back and review back through that, because we can do more work with the Punnett squares if we need to, as far as making them. I can have you make them or something like that. So let me know, give me some feedback on that if you need additional stuff with the Punnett squares. That way we can go through that and get y'all set for that. So what I need you to do is just have all that read, make sure you're good on it, and that'll be today's lesson. So I hope y'all have a good day.